I had a quick one. We've got one that's trying to join, and they're getting a request for a passcode. Is there a Zoom passcode they need to
Uh,
enter?
the passcode is in the link in the
Oh,
wiki. So if you just send them the wiki link there, you can also click here in Zoom. Up to your left, you have a little meeting information, and that gives you the entire invite link. So you can just copy and paste that to them.
okay. Thank you very much.
Sure thing.
I put it in chat. That helps.
Thanks, Steve.
Yeah. Does anyone have anything they want to chat about, or any questions or anything? Or well, I didn't know we had in the schedule today. I know, Jonas, you asked me, "Are you ready?" And I was like, "Ah."
Hey, Steve, I got a quick question for you.
Yeah.
So that meeting that we had the other day on getting up and running, is that video on YouTube yet? I was checking, I think a little while back. I didn't see it up there.
That's on me. It's coming up.
Okay.
Yep.
No problem.
Yeah.
Just wanted to ask you about that. If I was maybe missing that. So.
No, yeah, Jonas was on vacation for some time, so he's just backed up with everything. So
Gotcha.
yeah, he'll do it sooner than later.
Cool. Hey, I'd love to learn a little bit more about your new release and some of the performance improvements. I think that'd be just a maybe interesting thing to talk about today if we have time.
Yeah, we can do that for sure. Let me grab a window here. Okay, so I can share desktop on, do the whole shebang. There we go. Yeah, so we did a release last night, or depending on your time zone, if you're on Australia, it was yesterday morning. But so this one was to, the primarily one was to fix some performance issues. So Matt Moore, he's one of the folks that works on Knative. He was doing some load testing so there's this thing called net contour. So net contour Knative. So if you run Knative, you can actually run contour as the ingress controller that does all of the routing bits. So this is the repo for that. So I think in all the Knative docs, there's a way that you can deploy this, but this is the basic repo for that. So Matt was doing some performance testing of contour running in Knative and ran into some things where on an older version, I think he had like a 2-minute delay, and then on the newer ones, it was like 5 minutes or so, like something much larger than it should have been. So he did some digging and figured out that some of the issues he had was tied to the status updates. So Contour writes status back to the API server for ingress objects as well as HTTP proxy objects. So things like the load balancer address for ingress, as well as just is the resource configured properly or not. So in there, he found out that there was this basically like there was a resource overwhelming the API server with updates and hitting some rate limiting. So I think here in the notes, Nick put some good description. So when we built the graph, we'd hit the API server rate limiting, right? So we'd cause so basically all the status updates would back up, and then they would get stored back in time. So we'd have to over time keep that list grow to push that through, and that was causing the issue. So to test it, to verify it, Matt went and turned off the status update, and just ran it. And then I think the performance went down to like seconds from minutes. So we narrowed it down to that being the bit. And then Matt went and sent a PR in here. I think that's this one. Maybe Nick did the PR. He made the channel buffered here. That was I think there was another PR that Matt had filed.
Yeah, there were two.
There were two.
There's a link to the Matt's one there.
Is it this one or is it down here?
That's
1.8.
Oh yeah, that's just the cherry pick PR into the 1.8 release branch.
I don't know where it is, but I forget. But we can find it. But that was the TLDR, I guess. The big thing was status updates was working fine. It was just a matter of when you had a large cluster with lots of proxies and lots of objects, you could hit this thing. And I think the performance test that Knative runs spins up like 500 proxy objects or something like that, and then sends traffic to all of them and everything. So yeah, that was that.
I think what specifically what Matt found was that every time we went to do a status update, we were first getting the HTTP proxy from the API server, even if we weren't actually going to update it. And so we're doing tons and tons of gets. And so he changed it to use the Informer cache to actually get the proxy resource and check and see if we were actually going to modify it before submitting the patch. So saved a whole bunch of calls out to the API server.
Okay. Yeah, you're right, Steve. Thanks. Yeah. Yeah, here's the PR. So this is 2864. And this one was replace the dynamic cache get, or the dynamic client get, which was uncached, with a read from the Informer's lister cache. So this code path was evaluated for every proxy object on each DAG rebuild, and the call to the API server on each results in a thundering herd that triggers the built-in rate limiting in the client go. So yeah, so this, I think it was a pretty small change from what I remember. Yeah. Here's the lister. Yeah. So that was the big one in 1.8.1. Nothing else was in there short of those two fixes. Then one, go ahead.
Oh, so how would you define as a large cluster would be the number of HTTP proxy objects? How would you define that? Is it just the number of HTTP proxy objects? And is this kind of like a exponential type issue, or is it kind of like linear in terms of, like, you know, if you get to 250, it'll take 2 seconds. If you get to 500, it'll take, 5 seconds or whatever.
Yeah. So, sorry, go ahead. Yeah.
Oh no, yeah. And what is large? Is 100 large? Is like 1,000 large?
Yeah, we've had users. I've heard of users that I know when we wrote Gimbal, and this has been some time now. But Gimbal we tested, I think, with like 5,000 services, and I forget how many endpoints we had. That's kind of getting big. So there's a couple different things to think about, right? So one of the things that I know Nick did before was status updates was tied to the DAG rebuild, and I know this one sort of was as well. But the goal for status was to pull it out from the DAG rebuild so that status updates could happen in a different process, because we have status updates for proxies as well as ingress objects. So they're kind of two different places. And I know we're looking to add condition support as well. I believe Nick has a design, some PRs on that. So we're going to look at adding. So right now, status is just, I guess I could show you one. Y'all might know, but I'll just do it because it's nice to look at things. Kube control, get proxies, describe proxy, my ingress, how appropriate of a name. Come on. There we go. Yeah, so down here you can see that we have status. So right now we have basically, is it valid, thumbs up or thumbs down, and then a small little description, and then the load balancer if you have one. This is actually running in my house, so there's no load balancer in front. So looking to add a set of conditions to that. And Nick has a design doc here, for conditions, which outlines basically that can become a set now. And this is mirroring the upstream service APIs work. So the idea here, instead of having basically like, here's the thing that's wrong, it's like, here's a set of things that could be wrong or just informational about what's going on with that resource. So that's going to get tied into all this as well. Anyway, back to your original question. So that was status. So that was the issue we saw here, was writing that status back, basically slowed down the client and contour, and then that made other updates happen slowly. What makes a big cluster is, so the more services there are and the more endpoints and the more objects, like ingress objects, that would make it busier. We've never really had an issue of like the DAG rebuild time taking too long, but there is a back off in there. So if you ever watch, look at the logs of contour, you'll see there'll be like this last update, outstanding one. There's like a back off timer basically baked into there. So the idea is that when a whole bunch of objects come through, what we used to do is we would update for every object, and we built a new DAG, and that got out of hand obviously quickly because every object, there could be a whole ton of updates in the cluster. So we moved to a way where we would kind of batch up a bunch. So every time we rebuild the DAG, it's based on the current state of what Contour knows about the cluster, right? So we don't process, Contour doesn't process like oh, the service got added. Now let's go add that to the configuration and then send out that change. Contour says, hey, here's all the services I know about. Here's all the routes and all the objects I know about. It builds a configuration off of that and sends it out. So it kind of burns up more CPU cycles in a sense, just because you're always recalculating from scratch, but it gets out of that mode of having, issues where you get out of sync with reality of what the cluster is doing. So the DAG update here has a back off sense. So it'll wait a certain period of time. So I think it's 100 milliseconds or something. It'll wait that time if it doesn't have any other changes and rebuild, or to rebuild off of a certain set of objects. So yeah, that doesn't help answer your question, I don't think either. So scaling is...
No, it's fine.
Yeah, I'm trying to talk through it because I don't have a good answer. I know it's come up before with like, what resources should I give Envoy and Contour in terms of memory and CPU? And a lot of it too depends on lots of things. I think before I did a perf test of things, this is a while ago now. Resource limits. Yeah, this is on 1.12, so this has been a while. But this was the test that I sort of did. What did I throw at it? Yeah, so we spun it up, Contour had 10 megs of memory and Envoy had 15. Throwing 5,000 services at it without any traffic. Envoy stayed the same and Contour used 46 megs of memory. And then I started throwing traffic. So 10,000 services, 10,000 ingress objects. Contour used what? 2 gig? That can't be right.
Yeah, 2600 gig or 2600 megs.
That seems like too much. So we should do this again. And then Envoy went up to 430 megs, which was still good. And then I think we did, this makes no sense, with 0 traffic to have no services or ingress objects, but send traffic at it. So we should redo this. I'm willing to bet there had been objects in there. But this ties into there as well, but nothing was crazy in terms of numbers. We used to have memory issues, and I think that got fixed with a couple of things in Contour as well as an update in Envoy. So this is the extreme end, I think. If you've got 10,000 services and 10,000 ingress objects, that's a pretty hopping cluster.
Yeah, there was an interesting link I saw, Steve. It was about, I've got like a little gist where I keep a bunch of Kubernetes links. I'll send that over in the Contour channel, but it kind of talks about Kubernetes limits too, which kind of may be interesting, to kind of take into account.
Yeah, sure, absolutely, that'd be great. Great to share that.
Yeah, because they kind of talk about how when you're trying to figure out like, okay, what are the cluster limits, right? And it's actually a complex question, and I think they make some kind of good points in this little article. So
yeah, I know we did a lot of load testing of Gimbal. So Gimbal's job was to make sure we didn't add extra latency to the request. So from the external load balancer to the backend, service pod, in that case could have been an OpenStack VM. We were trying not to add too much latency to that request when we found that we didn't. But where was I going with that? But we found that we would peg the network much faster than pegging the CPU memory of the machines. So the network became congested and filled up way before ran out of memory or CPU. So that was, again, that's not the same thing. I get it, but it showed, I guess, Envoy was being a very good proxy, as it should be. I would expect it to not use a whole lot of memory. But it kind of depends on what's going on. I don't have much production clusters that I can see running Contour. From where I sit as the open source person. I feel like I'm rambling now, but it all depends, right? So yeah, the more stuff you have, the more it's got to chug through and process. But we haven't really had a whole lot of issue with that. So if people do, I'd be curious to hear about some of your problems.
Yeah, definitely.
Yeah. See if there's any. Where's my chat? So what else? Anyone else have anything else Did I answer your question, Chad? Is that?
Oh yeah, no, absolutely.
okay.
I just thought that was really cool.
Yeah.
I was trying to better understand, and it's kind of interesting because I've actually the past couple of weeks been doing a lot of like Kubernetes automation, like essentially integrating with API, and I've been working with informers and watchers and the whole. I think essentially what you're saying is you guys went from polling, essentially like performing a bunch of GET requests to kind of event driven, right, for updates and stuff. So definitely
Yeah, I know that. Yeah, the first version of Contour used Envoy would pull Contour for XDS updates, and that was before like the gRPC stuff existed, I think.
Right.
And then Contour went and implemented the gRPC interface. Then we could stream that stuff down. So yeah, that was good there. Yeah.
Cool. Yeah. Thanks.
One thing that I wondered is that when the changes are then sent to Envoy, what then guarantees, what makes it work so that the configuration, the new configuration that replaces the old configuration is somehow taken into use in a consistent manner, like as a transaction, that every resource will be in place and there is no any hiccups during streaming these new configuration items.
Well, there could be some hiccups. I mean, that's actually another issue that Matt has raised with Knative that he's seen. So let me see if I can find that one. So basically what happens is, if I can type and talk at the same time, Knative had some issues where they swap out services quickly. So they'll have, service A configured and then he'll swap to service B quickly. And what can happen is that the change will hit Contour at some point, and then Contour's got to stream that down to Envoy. So there could be, a route configuration change as well as a cluster configuration change, and then a set of endpoints. So those three things need to hit Envoy all at the same time to make sure that you don't get a down or a 500 request or a bad request from a user. When that happens, like when in some of Matt's Knative tests, they're happening very, very quickly. And he had some issues where they broke, where he had, didn't get a successful response code from Contour. I believe Matt did a change in this to handle that. So there's two things we can do to address that in Contour. So one, this is happening so quickly, I think he's finding it because it's a unit test, but I guess it can happen. Part two is that we could switch to a thing called ADS. So right now Contour exposes a gRPC connection for every XDS resource. So I guess I could show you, I have a slide here real quick. Let me go find this slide. I have a good slide that explains this. Envoy, where's Envoy? Nope. Okay, I'll show this back. Okay, this is a talk we did last EnvoyCon. Oh, it's not in here. Where is it? No. Maybe it's this one. Who else has like Google Drive issues of finding the right account? Here we go. Yeah, this is a good picture. So this one has, this is a good view of what Contour does, right? So down here at the bottom, these are all the different services that Envoy offers. So there's some more, but this is what Contour implements. So you can think of Contour as a translator between Kubernetes and Envoy objects. So any service in Kubernetes gets translated to a cluster in Envoy down here. That's called CDS. Secrets or certificates that we pull in from the cluster get mapped to SDS. Endpoints go to EDS for endpoints. Routes hit RDS, which essentially they're actually cluster load assignments. I'm sorry, endpoints are cluster load assignments. And then listeners map to LDS, which are listeners. So you can see here that Contour watches for all these objects at the top, builds that DAG in it, and then passes that down. But there could be a time, and so every one of these services down here becomes a gRPC stream or connection between Contour and Envoy. So 1, 2, 3, 4, 5. So now if you have one Envoy with one Contour, you're going to have 5 gRPC connections to Contour today. there's a thing called ADS. And what that does is it proxies all these different XDS endpoints over one gRPC connection. So then you can have basically they're one-to-one then. So every instance of Envoy has one gRPC connection back to Contour. And that can get expensive the way it is today, right? So if you had 100 Envoys, you're going to have 500 gRPC connections back to various numbers of Contour in the cluster. So then there's a thing you can turn on called ADS, or no, what is it? ADS. Oh, it's been a while. What's the thing? There's a validation when you do this. Here, we'll go to Go control plane. There's a flag you turn on that tells it to basically do what we're saying about Taro. So it does is it validates the objects that you're sending. So if you send it, say, a route related to a cluster that doesn't exist yet, the Go control plane will reject that information until you get that configuration updated properly. So then when you're streaming that information down, you're only streaming, a full manifest that's valid.
So it almost makes it like transactional.
Yeah. So we're looking to move to this Go control plane. So I have some PRs now that I'm pushing through. And we're going to actually add this in parallel. So you'll be able to. So what we don't want to do is swap out the whole backend XDS control plane and here you go, run this on production, because I'm not scared of it, but it's just a big change. So we're going to let this run in parallel so we can start turning this on in certain places to see how it works. So the difference of what the Go control plane does is it is transactional. So you create these things called snapshots. So this is probably an example here. Yeah. So you create a new snapshot cache, and then you generate a snapshot. And that snapshot is sort of here's the listeners, here are the clusters, here's the routes, here's all the things that you care about. And then we'll send it over to Envoy. And then that gets passed over to Envoy. Let me set that up. And this is the bit I'm looking for.
So the difference being, because all of those APIs are combined into one connection, you can commit them all simultaneously.
I think it's that, and then there's less churn for less, because every gRPC stream can be expensive in Contour, right? Having that resource configured and running all the time. When we had memory issues before, this is actually in this talk here. So some of this, the memory issues we saw, this is 70 gigs of memory, which is a lot, but some of this was just gRPC connections that it was maintaining, because this user had a very large cluster that they were working with. So that helps remove a lot of that churn, or a lot of that overhead you might see with memory. And then it is called ADS. So here in the code, when you create the snapshot cache, this false or true is whether you want to turn on ADS or not. And when you turn that on here, it adds a consistency check to verify that the caches all have the right things in there. So that should be coming very soon, this new swap out to the Go control plane, and there'll be a flag again. It will default to the current Contour XDS server, but you'll be able to buy into it. And then once we have that in, that'll help set us up for a way to move to the version 3, XDS v3. Right now we're still on v2, because at the end of the year, Envoy is going to deprecate v2, so it won't be supported any longer. So we have a path to move that out soon as well. And those are in Contour here. And mine's been sitting for a while to get in. I had a talk yesterday at Spring One, and I feel like talks take 2 weeks to do a 30-minute talk. This is the one I'm going to wire in, yeah. So this one will come in next, which this adds snapshots to the DAG rebuilds. And this is hard to read here. Where's my snapshot handler?
I would like to figure out how to turn these inline code coverage things off. They seem to just start appearing recently, and they're super annoying.
I blame James. He's not here, so I can blame him, right? They're cool when you're reviewing, because it helps, but it also gets in the way sometimes. Plus, my font's big. I don't know where it is. Here, I can just show you in here. All right. I think my window here has got it all blocked. Okay, here. So snapshot cache. There goes my water. Yay. Hang on. Water on a PowerShell is good, right? Okay.
At least we know the reason if you drop out.
Let me grab a towel real quick so I don't electrocute myself. One
Yeah,
second.
take your time, Steve.
I don't know, Steve. I know on today's talk we talked about doing. I can show you this if this matters, but it's not all that interesting. About how the DAG got rebuilt and how we convert from events to XDS. I don't know. I know, Steve, you just did a bunch of rework there with the builder piece, where you extracted out the builder into separate interfaces. I don't know if you want to talk about that, or if anyone wants any other questions.
Yeah, I was also going to do a demo of the gatekeeper stuff, so I could do that now if you,
yeah,
if
you
you
can do
need
that
a
if you
few
want.
minutes.
Yeah, I just need to. There's just water like everywhere, so I need.
All right. Yeah, I'll
right.
do that. It'll take a good chunk of time.
Okay.
And I need Steve to stop sharing his screen.
Let me see if I can kick him.
Yeah, I'm not sure how to do that.
There we go.
All right. Just rearranging stuff. All right, yeah, so over the past couple of weeks, I'm sure some of you have heard me talk about this already, but I was working on putting together a guide and some sample configurations for using Gatekeeper alongside Contour. And so for those of you who aren't familiar, Gatekeeper is related to the Open Policy Agent project. And specifically, it's an admission controller for Kubernetes that uses Open Policy Agent and Rego to allow you to define kind of policies or constraints that you want to enforce as part of the Kubernetes API server processing as resources are being created or updated. And so the idea here and what got us thinking about this was that you know, currently when you define, basically as a user of Contour, if you're defining HTTP proxies, Contour will do a bunch of validations on those and ensure that they're configured correctly. But currently that doesn't happen until after the HTTP proxy resource has been created in the Kubernetes API and the DAG is actually processing. And so the way that you as a user would see if one of your resources is invalid is that eventually Contour would set a status on it that says this proxy is invalid, and it would give you at least one of the reasons why it was invalid. And so that's fine, but it means that as a user, you don't get immediate feedback if your proxy is invalid. You kind of have to wait until Contour processes it and then go check the status and actually see what's going on there. And so with admission controllers in Kubernetes, you can actually define logic that happens as the resource is being created that enforces you know, whatever validations you want to apply there. So you know, we could, if we're using an admission controller, we can enforce all of those validations on the proxies, you know, to ensure that kind of required fields are populated and that there are no conflicts with other resources. So so anyway, yeah, I wrote up this guide, which is kind of a walkthrough for how to use Gatekeeper with Contour. And we've started to create some example configurations for that in the Contour repo. So I'll just kind of walk through some of this. I'm going to loosely follow the guide, but may go off a little bit. And definitely, if anyone has questions as I go through it, feel free to jump in. So yeah, so the first thing, so I have a kind cluster set up, and I have Contour installed, but I don't have Gatekeeper installed yet. So the first thing I'm going to do is install a Gatekeeper. Keyboard's being super laggy here, so I'm actually gonna pull the laptop off the stand and just do this. Just give me a second here. Gotta rearrange everything. All right. So yeah, so first thing I'm going to do is deploy Gatekeeper, and getting an off-the-shelf Gatekeeper install is super simple. So if you look at this command here, this is basically pulling some YAML out of the Gatekeeper repo. So I'm just going to run this. And so this is going to set up a Gatekeeper namespace. So we've got the Gatekeeper system namespace now, and if we look at the pods that are in there, should be up and running by now. Yep, so you see we've got a few different pods, or I guess 3 replicas of the controller manager for Gatekeeper, and then also an audit pod, which we'll get into in a little bit. So that's the first thing, and then what we're going to do next is apply some configurations to it. So the first thing that we're going to do is, so if you go into the Contour repo under examples, we have a Gatekeeper directory now that has all of the kind of sample YAML that we're using. And the first thing we need to do is configure Gatekeeper's cache. So so by default, Gatekeeper operates as an admission controller, which means that essentially when the resources that you configure are getting passed to that admission controller, Gatekeeper will see the full kind of spec. So they'll see the spec of that HTTP proxy. But if you want to write admission checks that look at other resources in the cluster, you need to configure Gatekeeper to have those in its cache. So in this case, I want Gatekeeper to keep in its cache all HTTP proxy resources, and that'll allow me to write admission checks that look not just at the resource that's being created, not just at the proxy that's being created, but actually look across all the other proxies. And so that allows me to do things like enforce unique FQDNs across all the proxies. So yeah, what I'm gonna do is just, let's see, apply that config. That'll tell Gatekeeper to cache all those proxies, and then we're good to start going through this. So the next thing I will do is look at some of the constraints that we have in this validations directory. So we've sort of organized the Gatekeeper constraints across what we're calling validations and then policies. And so validations are basically things that Contour always requires to be true. So, an example of this is that every HTTP proxy has to have a unique FQDN. And that's something that Contour already validates internally, and will mark your proxy invalid if it uses the same FQDN as another one. But so we can implement that as a Gatekeeper constraint as well, and get earlier feedback. Another example of this would be every proxy has to define at least one route or one include or a TCP proxy. So essentially it can't be empty. And so those things always have to be true for every Contour install, and they're already being validated internally in Contour. Separately, we have policies, which are things that a particular Contour administrator may want to enforce for their cluster, but they're not required for Contour to run correctly. So examples of this may be that you don't want to allow any proxies to have timeout values of greater than 2 minutes, for example. So that's not something that Contour requires, but you as the Contour administrator may want to enforce that for your setup. So we'll look at the policies more in a minute, but I'm going to start just by looking at the validations. So we can open up one of these and just look at the details, and I'll take a quick pause there and see if anyone has any questions or comments. All right, so yeah, so this is the what's called a constraint template that enforces that essentially every proxy that you define has to be non-empty, meaning it has a route or an include or a TCP proxy. And so within Gatekeeper, you have constraint templates, and then you have constraints. So they sort of are what they sound like. The template is kind of a generic basically defines the rego that actually implements the admission control check. But it can have parameters, and then you can instantiate that template into constraints with different parameter values set. So actually, neither of my validations have any parameters, but we'll see some with parameters when we get into the policies. So if you're not familiar with Rego, it takes a little bit, or at least it took me a little while to kind of wrap my head around. But essentially, this code is checking the HTTP proxy that's being created, and that's defined in this input.review.object field. And it's essentially saying that if it's a root HTTP proxy, meaning it has a virtual host defined, and it doesn't have any routes, it doesn't have any includes, and it doesn't have a TCP proxy, then essentially that proxy is invalid. And so we're gonna define that it's a violation and provide this message. So I'm gonna go ahead and apply these things to the cluster, and we'll actually see them in action. So yeah, I'm actually gonna apply this whole directory. I'm gonna have to do it twice because when you define a constraint template, Gatekeeper automatically creates a custom resource definition to represent that constraint template. And then when you define a constraint, it's essentially instantiating instances of those CRDs. So we have a little bit of a race condition here, but we'll just apply everything. All right, so now if we look at, we can just say get constraint templates, we'll see that, you know, this non-empty constraint template that I was talking about and another one that is called unique FQDN have both been defined. And then what we can do is, so each of these are represented as a CRD, so we can actually say, get the HTTP proxy non-empty CRDs. And there's one of those which corresponds to this, this file here. And so this is just instantiating that template into an active admission control check. So anyway, let's get into looking at an actual proxy. So we've now said that every proxy has to be non-empty and it has to have a unique FQDN. So the first thing I'll do is in this file, I'm just going to comment out all these routes, right? So we have now a proxy here that defines a virtual host with an FQDN, but it doesn't have any routes or includes or TCP proxies. So, so this should be invalid. So if we just apply this. So, so now you get an immediate error from the admission controller from Gatekeeper that says proxy must define at least one route, include, or a TCP proxy. And so if we look in the cluster, we'll see that proxy wasn't actually created. So it was rejected by the admission controller. And so, so in the past, without Gatekeeper, you know, if you created a proxy like this, it would create successfully, but then it would eventually be marked invalid because it didn't define any of these things. But so now you get more immediate feedback, and you can go actually remediate your proxy. So yeah, so now I've added routes back to that proxy. I need to save it, and so now it creates just fine since I've actually added some routes in there. And then, so the other check that we defined was every proxy has to have a unique FQDN. So up here, we're using local.projectcontour.io. So let's just try defining another one that uses local.projectcontour.io. So if I apply this again, the first one didn't change, but when it goes to try and create the second one down here that uses that same FQDN, we'll see that we get an error and basically says that it must have a unique FQDN. So again, this is another example of something that previously would have been surfaced in the status of the proxy, but now you get that feedback immediately as you're trying to create it.
And it didn't break your chain. We've had issues before where some of these validation errors would disable the routes because they were in error then. So yeah, this
right.
gets around that as well. So, which is great.
Yeah. Yep. So now if I remediate that, then they both create just fine. So yeah, that kind of covers validation. So hopefully you can see how that's useful. And I think, over time we want to add to the list of validations that we have here, so that essentially everything that Contour is currently checking internally within the DAG build, any of those that make sense to validate upfront as part of the Gatekeeper run, we have a file here for. So if you're using Gatekeeper, you can just apply all of these to your cluster, and you'll just get earlier feedback if any of your proxies are invalid. So then the next thing to move on to is the policies, and these are, again, things that Contour doesn't require to be true, but that you as a cluster administrator may want to enforce for your cluster. So a good example of this that we've heard before is around enforcing timeout ranges. So Contour lets you define various timeouts for your proxies, but some administrators may want to limit the allowable values for those timeouts. So I'm not going to go into detail into what this rego does, but the kind of important thing is that this is the constraint template for timeout ranges, and it takes 3 different parameters. So it takes a minimum and a maximum, so you can define either a minimum or a maximum or both for your timeouts. So you could say, I don't want any timeout to be greater than 2 minutes. And then it also takes a field as a parameter. And this basically is just a way of reusing this one template across all of the different timeout fields. So when you actually instantiate this template, you tell it which timeout field to validate as a parameter, and then you give it the range. So if I go into the constraint for this, one of our sample constraints for the idle timeout range, you can see in the parameters here, I'm specifying I want this to run for the idle field in the timeout policy, and I want a maximum of 5 minutes. So I'm going to go ahead and apply these 2 files. So let's see, policies, timeout range. So that defined the template, and then do the idle timeout range. So now we've said that all the idle timeouts have to be at most 5 minutes. So I'll go back into my proxies here, and I'm just going to work the first one for now. So what I'll do up here is, first I'll define an invalid proxy. So I'll put an idle timeout, and I'll try to set it to 6 minutes. So see what happens here when I try to apply the proxy. All right, so we get a big error here, which is a little bit difficult to read, but if you look at the top line here, we're essentially saying that, we essentially got an error message saying that the idle timeout must be less than or equal to 5 minutes. And you'll note that in this case, this proxy already existed in the cluster, and since I was reapplying it, it was trying to update it. So by default, Gatekeeper is configured to run on both creates and updates for proxies. So it'll prevent invalid configuration for either of those. So I can go back to my proxy here, change the timeout down to 4 minutes, apply it again, and it goes through just fine. So that's pretty nice. And if you omit the timeout policy entirely, it also goes through just fine. So it's only going to enforce that if you actually specify a value there. So I'm going to set this back to 5 minutes real quick just to demonstrate one more thing. The maximum value is inclusive, which is why it lets me set an idle timeout of 5 minutes. So let's imagine now that as a Contour administrator, I actually want to change my policy. So previously I had a max idle timeout of 5 minutes, but I want to change it to 1 minute now. So the challenge here is, when you roll out a new policy like this, you don't necessarily want to break all of the configurations that already exist in the cluster. You don't want to break all your routing. And so Gatekeeper lets you do this. So if we apply this file, policies, so it applies just fine, but we know that our proxy that's defined is actually technically violating this policy now. And so Gatekeeper has the concept of an audit. And so what it does is every every minute by default, it looks at all of the resources that exist in the cluster and essentially reruns all of these constraints against those resources. And then it will report in the custom resource if there are any violations against those policies. So let's see. So if we do for the timeout range, if we say, if we look at this constraint here, so we can just describe it. So it's going to run every minute and show an audit report in the status for that constraint. So you can see here, it's actually already run since I've made the changes. So it shows you the timestamp that it last ran. And then at the bottom here, if you have any violations of the policy, it'll surface them here. So in this case, it tells you that there's an HTTP proxy called P1 in the default namespace that violated this constraint. And so now, as an administrator, you can periodically check this and then go tell your app developers or the folks who are responsible for defining the proxies to go remediate their proxies. And once they update that value in the proxy to be within the valid range, this violation will go away from the audit report. So yeah, I think that's pretty much all I wanted to demo. So, we have a few other examples of policies that you might want to use within here, but certainly you should, if you're interested in using this, you should feel free to kind of customize these or add new ones, based off our examples, based on your specific needs. And over time, we hope to kind of build out the set of validations that we have and also add some more example policies to the library here.
Well, that's pretty cool.
Yeah, that's awesome.
Yeah. I don't think this is a done list either. I think there's also more we could add, to the stuff you've set up, Steve. So in terms of the policies and all the things that you could potentially configure. So if folks want to add more, you can comment. Obviously some of the values made, like the, excuse me, the timeouts made to match what your specific use cases are, but by no means is this all. So this is intended to be a library of things that you all can leverage to then, make your clusters more consistent, I guess.
Yeah, this is really cool. Thank you for showing that. That's really nice.
Yeah, sure. All right, well, that's all I've got. I guess I'll stop sharing if nobody's got any other questions.
Anyone else have anything that came up they want to talk about or ask about or chat about? Feel free to chat it or just unmute. Yeah.
So I'm pretty new to using Contour, and the other day we had an outage in production that was very brief, but it was related to our Contour pods dying, and we lost all routing inside of our cluster or something to that effect. Good ways to diagnose or reproduce these kind of conditions would be definitely something that I'm interested in. But like I said, I'm very new to all the Contour stuff at the moment.
So you said so Contour died, or did Envoy? I guess what
Contour died.
Contour died.
Yeah, the pods were killed, and so we no longer had dynamic configuration for Envoy, and so Envoy stopped serving traffic for us for a brief period of time.
Because usually what should happen is Envoy it's kind of like Kubernetes, right? If you pull the API server out from under Kubernetes, it'll use kind of what it had last. So if
that's what I would have assumed, but
yeah.
We experienced that outage. We haven't fully figured out why it happened yet or what happened. That was just the only thing that we could diagnose at the time was was that the Contour pods were dying.
Okay. I know there was one user that came up that said that at one point they had, again, they had a very large cluster. This is back to your question earlier. And I think what happened was when they spun up a new instance of Contour, when an Envoy would switch to it, it didn't have all of the configuration yet from the cluster because it was still churning through all of it. And what would happen was Envoy would have a working config that was valid, but then when the new version of Contour spun up, it didn't have all of the information yet, right? So then basically it would tell Envoy, hey, here's your new config, and it would trash a whole bunch of routing configuration out of Envoy until it caught back up again, then it would then send it over. I know Contour, we have now a wait, and we should probably add some feature tests for this. But it'd be hard to test, but there's a wait, basically wait until all of the objects get cached by Contour to then process the DAG and move on. To try and avoid that situation. That's the only thing I could think of that would happen possibly if somehow what Contour knew about the cluster changed and then it reprogrammed the envoys incorrectly.
Yeah.
It'd be interesting to see. If you dig in, let us know or post, DM us or chat us, however you want to, whatever you want to share. I'd be interested to see too, because I'd like to come up with ways to not have users run into that, in the future. If we can code in things that help that.
We're also running an ancient version of Contour, so that's the other half of it that we have to get around is running a more recent version.
Okay.
Cool.
Yeah.
Thanks.
Well, sorry about that. I feel
it's okay. Hey,
I feel half responsible because
it was 5 minutes of torture, but we made it through.
Gotcha. Cool.
I had a question about the wait. Is that effectively it doesn't bring up the XDS connection until it believes it has a complete set of the information, or like how does it prevent Envoy from pulling an invalid configuration?
I think I think you're right. I think what we did, I could show you the code. I think what Contour should do is it shouldn't start the gRPC server that Envoy uses to connect to until that happens. So that would be over here. It should be in serve.go. I'll make this bigger here in a second. Or no, it's in this one.
Wait for sync.
Yeah.
Is that it there?
Yeah, this right here. So the goal of this is built into the client Go. So this should wait for this should wait for the cache, the internal client Go cache to get all of the resources out from Kubernetes first before it does it. But I think this was a first step. I think we should also add a check to wait for the first DAG to get rebuilt, right? So it's not so much that like having all the objects is great, but Contour may not have processed them all through the DAG yet. So a better step would be to get all the objects, process the first cycle of the DAG, and then spin up the gRPC endpoint. I think that would be a better solution.
Yeah, I'd be interested in debugging and working through this. So
yeah,
I'll definitely take a look.
There should be an issue somewhere, I think, on this, but if not, go ahead and create one. We can just merge them together. Go ahead, Joseph, or you're going to say something else?
Not much else, other than if anyone is interested, for people not aware, I have contributed support for Contour in external DNS, which we've been using in production for a couple of months. So if anyone is not using that and is interested, there's a PR open that will hopefully get merged soon. Yeah, it makes convenience of working with Contour HTTP proxy objects a little bit nicer, because previously you had to use ingress if you wanted it to work with external DNS.
Yeah, thank you for all that. Yeah, so that's fantastic. I know you had ingress route support in external DNS, and then Joseph, you went and did all the work to do it with HTTP proxy. So that's great. That's the first step to getting us off of the ingress shim sort of thing. So thank you for all that. That's great. That hasn't merged yet. I've been trying to watch.
It's just waiting for maintainers to get around to merging it.
Okay. Oh, that's the wrong issue. I was looking for the issue just to put it in the notes because it's cool. Here it is. Blink. So this is it, 1628. So once we get this in, then you can just use your HTTP proxy to then manage external DNS. That's awesome. And you've been using it in production, you said, so that's
Yeah, we've been using it for some time. It works well for us, so yeah, hopefully it'll be in soon for everyone else to use.
Very cool. Yeah, that's fantastic. I think the next thing to do then is to update Cert Manager to know about proxy objects. Then we can ditch the.
Yeah, that's part of it. The other thing is to use Cert Manager instead of the search gen job that ships with Contour.
Mhm.
I'm already using the self-signed assigner. I did post some examples of how to do that in Slack, but I could potentially contribute some a document to the repository if anyone wants to do that instead of using search gen.
Yeah, that'd be fantastic. I think a guide would be great for that out here in this guide section. Because we have, I think this one is how to just get generic certs, but yours is more of how to do the communication between Envoy and Contour with cert managers. That'd be great.
Yeah, correct. Yeah,
Yeah.
It makes it a little bit nicer, especially if you're trying to run multiple instances of of Contour in the same namespace, because you can prevent them from conflicting a lot easier.
Very cool. And this comes back to, I know some folks are working on, there's a Bitnami Helm chart folks are working on in terms of deploying Contour. I think we're looking to move that into the Contour repo proper, just to have it, live in our space. I know there's some folks also looking at building an operator for Contour. So if anyone's interested in that, there's the underpinnings here of starting that out, just to play around and see how that might look. So you can, have CRDs and stuff build out all of your configuration that way.
Yeah, is there an issue or any documentation on how to approach cert manager support proper? So that's when you create an HTTP proxy, have it automatically allocate a let's encrypt cert.
Yeah, I believe they moved. Last time I talked to James Mulaney, cert manager, he this is probably a year or so ago. They were looking to switch how cert manager used to do these conversion webhook things. So the idea was, so they would do, you register a callback to say, hey, go implement the callback hook, and then once it's there, then it'll continue on. I believe that's in there now, in the repo to do that. So now we just need to just wire all those bits up. And just figure out, assuming Contour would expose that extra endpoint for that cert manager could call back into. So we just need to figure that out, what that looks like.
The Acme request, right?
Yeah. I think basically cert manager will say, hey, I need you to go have this URL with this bits, with these validation tokens or whatever it needs. Go create a resource with this, and we can go generate a proxy object under the hood to then to do this. So I don't know if it should be in Contour, if it should be a separate tool. I don't know, because you'd have to give Contour then write access to create these proxy objects, right? RBAC permissions, I guess, is what I'm trying to say. But yeah, we should figure that out, because that'd be great. Because then once we do that, because we were chatting about that, so Steve Chris online, who just gave us that demo, did a bunch of work to split out how the builder types work. So in Contour, we had this big file called builder.go. And what that did was it understood what a ingress object looked like, what an HTTP proxy object looked like. And then coming up, we're going to add the service APIs work into Contour as well. It was all kind of smashed together in one big giant Go file. So Steve did a lot of work there to help split those apart. So now what we have is these processors. So here's the ingress bits. You can see that. So now this ingress processor knows just about how to process an ingress object. So now I guess our question was, should we support all of these things concurrently? Should Contour be able to serve ingress objects alongside, proxy objects in the same cluster? Because there's some weird things that can happen when you have things overlap. And we've been reluctant to do that yet, just because we don't have all the other things set up in the external apps, like cert manager, external DNS, all those sort of things, if that makes sense. So yeah. That's awesome, though. That's cool to get that in. I'll have to go see who else I know to ping for this one. Yeah.
I also saw Cert Manager went 1.0 I think yesterday. So we should
right.
we should double check our guide and make sure it, just update it to reference 1.0.
Yes, we should do that. Yep.
Hopefully it still works as is, but be worth a check.
Yeah, I think we have a generic or a specific version of Cert Manager. Yeah, what are we using still? This is probably stupid old 11. I'm sure that's really old.
Yeah, I might spend time just testing it with 1.0 and seeing if there are any updates.
So we'll just do an issue live. Called that update Cert Manager docs or guide. Ta-da! Cool. Let's label it with something. What is this? Site? Something. Yeah.
You can assign it to me if you want.
Boom. Whoop, not me. That's just habit there. I saw Steve and I went nuts. There we go. Cool. Yeah, and then Joseph, if you want to send that in, I was looking for that issue. Was it Cert Manager? But then there was the other one we talked about, the startup time thing, right? Startup. Yeah. All right. We don't have to stare at me looking at GitHub issues. Anything else anyone wants to talk about, or we can demo something or chat about something. And I think the schedule had, what was it? How we get events from Contour, and then how we process that through. Is it in here? I always get the wrong place. We can do that. We sort of did that in a couple of previous things, but happy to do it again. Happy to show whatever y'all want to see. Yeah. Oh, you did add that too, Steve. Cool. Yeah, the second one was how we watch for events, how we process those events, and convert that to Envoy XDS bits.
Yeah, that's interesting. Sure.
Cool. Yeah, and then I think James as well. This was how to design for failure. So Contour doesn't take down your clusters. That's a good one for next week or next time.
Cool.
Yeah. So do y'all want to hear about like how we do this with events and stuff, or I don't know?
Yeah, absolutely. I would.
Okay.
That'd be good for me. Thanks.
Yeah, we have another hour, so.
Oh, okay, good. I thought actually it was only 1 hour, so that's awesome. Okay.
No, this is
if you guys
scheduled
have time.
for scheduled for 2. I'm happy to do that. Yeah, again, I'm happy to about whatever y'all want to see.
Yeah, it'd be cool if you could walk through the process where it builds up from the information from the informer through to the DAG, and like,
sure.
Yeah, not necessarily in a lot of depth, but it would definitely help build a mental model.
Yeah, sure. Let me just get off of the branch I'm on, because I don't know what I've done there. Let's pull in latest and then. All right, cool. So now we're latest and greatest. Okay, so Contour. I have a picture here. Maybe y'all know this. So yeah, so Contour is an Ingress controller, obviously, and we have to watch. So we watch Kubernetes for certain things, right? We look for using Client Go. So Client Go is the tool we use to go talk to the API. So we watch for services, we watch for endpoints, we watch for secrets, we watch for Ingress objects and HTTP proxy objects. So when you deploy all that stuff in, let's see, it's in command serve.go. So this is where things start. I don't know if this is big enough. If I do this thing, it's like you can't see anything. I'll lose my menu. It's like too big then. I'll just zoom in with by hand. So command Contour, there's serve, right? So there's a bunch of commands that make up Contour. So there's Contour serve, which is what serves the XDS endpoints to Envoy. There is the cert gen job, what's a job run, so there's Contour generate certs. There's shutdown manager, and the shutdown manager's job is to help you reload or reinstantiate an instance of Envoy. So that helps shut down Envoy cleanly so it can drain connections. So what we're going to start with today is serve. So in here, this is kind of where all the stuff gets wired up, and then from there we can break apart into the other bits. So we create some informers, and we're using the dynamic client from Client Go. Part of that was to incorporate the service APIs work, because they didn't have a typed client, so we went to the dynamic one so we can just pull in new objects on the fly without having to regenerate a client inside of Contour. Okay, cool. So this is where the first bit starts. So this informer sync list. So these default resources define the group version resources that we're going to watch for. So here you can see there's HTTP proxies. There's the TLS certificate stuff, which we should talk about. That doesn't get enough love for how kind of cool it is. Here's services, then here's ingresses. So those are what we call the default ones. Down here, here's the service APIs bit. So if you have service APIs installed, which I doubt you do yet because Contour doesn't have support for it, but once we add support, then this will get spun up. This does it for secrets. So there are some times where we don't watch the whole entire cluster for secrets, and that's if you set the root namespaces flag, then we'll only watch those namespaces for secrets, and that's for security because we don't want to watch everything if we don't need to. Here's the endpoints bits, and then here's services again, which it's interesting that it's there as well. To figure out why that's there. But anyway, so this is where we create that list here to inform on everything. So this kicks off the informer. Whoop, pop this in here. So that's where we get that. And then what happens is we add these event handlers to it. So Contour manages its own internal cache, right, of resources. So basically when something changes from these informers, we'll get an event for that, and then we'll wire that through. And that should be this dynamic handler, which is here. So the event handler. So this bit here is what the meat and potatoes of all the event handler comes in. So let's hop into this and see. Yeah, you'll see here what we have is we have this interface. So add, update, and delete. So that's what the client Go lister is going to give us when things get added, updated, or deleted. So this is implementing that interface here. And then down here, there should be, that's the DAG rebuild. Here you go. So here's the onUpdate event. So update gets here, and this is actually, inserting the object into our cache or updating the object from cache or deleting it if it's removed. And that cache gets stored. It's in this builder bit. It's an internal DAG. There should be a cache. Yeah. So basically, on every add, update, and delete, it ends up in this cache here. This is our version, Contour's version of what Kubernetes looks like. Cool. We went through that far. So now at this point, you can assume that all of these different maps here are all filled up with all the objects that we're watching from Kubernetes, and they're updating real time as things change or as fast as we get them through Client Go.
So every pod essentially has these maps in memory, right? And is monitoring all these events and maintaining these maps. Okay.
Yep. Yeah, every Contour pod, yeah. And then there's so back here in this handler, there's this bit here. So this is where the DAG rebuild happens, is in this run bit here. So this ends up in a big giant like for loop. Yeah, so here's all the things that can happen in this loops. Basically, we're waiting for an event to come in. We're going to process an event, or that hold off time we talked about before kicks off, and that tells us to go rebuild the DAG. Yeah, here's this hold off delay that you can configure. I think it's like 100 milliseconds or something. I think Steve, you looked this up last time we had this question.
Yeah, we looked at it. It's like 100 or 500 milliseconds, something like that.
It's still pretty fast, yeah. So this is a loop that is basically, so all those events are coming through, and then this loop will determine when we're going to start the DAG rebuild. Where is here you go, rebuild DAG. So we call rebuild DAG, and this goes and says, so this is where we're going to take all of those caches that we have now locally, and we're going to go rebuild a new DAG in memory. So we call build, and this is should hit the stuff that Steve just did. Yeah. So basically now what we have is a set of processors. Make that a little bigger for you.
Quick question, Steve.
Yeah.
Sorry. So, okay. So you're getting these events, right? And so when you create an informer, you're receiving these events, which are essentially Kubernetes objects, right? You're like, okay, a new HTTP proxy was created, right? So you're going to do on add HTTP proxy. You're going to add that to the cache, right? And then this DAG that you're rebuilding, essentially. So two questions. Is this DAG a representation of like the relationship between all? So like you may say like, okay, I have a service that maps to this HTTP proxy, and the DAG is what kind of like maps those two things together. Is that like?
Yeah. So the DAG, yeah, it's a tree that, or a graph that represents your configuration.
Okay.
So yeah. So what happens is, yeah. What happens? So after we build this thing out, so this is where we're actually going to build that DAG. After we build this, then the next step is to walk it. So we'll walk down that tree and then pick off each type that comes out of that. So like, I'm gonna get good example of like the vhost and stuff. So we'll walk down all the vhosts and then build out the Envoy configuration next.
Gotcha.
Yeah.
So the DAG uses internal contour types so to represent it. So it's not quite the Kubernetes API types, and it's not quite the Envoy types. It's like an internal kind of neutral representation of the information.
So this is kind of like an AST then, right? Essentially, that converts from like Kubernetes objects to Envoy. Is that what this DAG essentially is? Like an abstract syntax tree, where you're kind of like maintaining these contour types and then like converting them essentially to Envoy, I guess XDS.
Yeah. So we take the Kubernetes types and we create this intermediate type. They're all DAG types. So in here you'll have let's go to one of the, there should be like a cluster. Yeah. So here's like a service. Here's a cluster. All these things mirror sort of how Kubernetes does it. And then everything after this point is all the same code. Right, so the job of this builder bit here, these processors, is to convert that specific type that you're doing. Maybe it's ingress or HTTP proxy or whatever it is. Convert that into this intermediate language, like you're saying, yeah, and then everything afterwards is all the same logic.
Gotcha. Okay. And when you say you do the DAG rebuild, are you literally rebuilding an entire tree, or are you just kind of doing ups like inserts and like removing leaves and trees, or are you just rebuilding the entire?
No, it's rebuilt from scratch every time. Yeah.
Okay.
So if you say you process it once now and then you wait 5 minutes and process again, it's going to use all of the bits in that Kubernetes cache that we have to rebuild it from scratch. So,
okay.
Which is again, I think it could be bad in a sense because you're rebuilding it again from scratch, but it's good because there's no errors in logic in terms of, because you're having to do diffs between what happened.
Right.
Is it so that let's say that in some of the watch namespaces a secret changed that will automatically trigger a rebuild for everything?
Yep, secret, which Now the only thing that shouldn't, I guess now it does. It didn't before, but now it does. So the only thing, I think it didn't trigger a DAG rebuild was an endpoint change, and I think we've since changed that. So now endpoints are only represented to what's actually used in the DAG, which is kind of better. So before, Contour treated endpoints differently, and that was because endpoints kind of update much faster than, say, services or endpoints or secrets. But the downside of how we did it was that every endpoint in the cluster got represented in Envoy, which could be bad, right? Because what percentage of your endpoints actually should be in Envoy versus what needs to be in Envoy? So now I think James just did a PR in looking at some other work he's doing for auth. Now only the endpoints in Envoy should match things that actually are going to get referenced from Envoy or from Contour. So basically any service that you're sending traffic to should have a corresponding endpoint in Envoy. Everything else shouldn't be programmed into there. Yeah, so this set of processors now must get built somewhere else. So it runs through them, and that's basically these bits here. So this is the logic to figure out. This is the HTTP proxy one. Where's the top? Here we go, run. So this is actually going to go build compute proxies. So it's going to loop through all of the proxies that it knows about. So here, here, valid HTTP proxies. So builder.source. So this set of source is then types back to this local cache, right? So it's looking at the local cache of what's there. So all the while this might be processing this cache behind it's getting updated. So again, this will loop through. It'll pick apart all the different bits it needs to do. You know, here's where it figures out like, hey, if you don't have a virtual host, we're going to mark it as orphaned. If you're using root HTTP proxies and it's not in the right namespace, we'll set the error there. If you don't specify a fully qualified domain name, we'll set that there. You know, all those different kind of errors you've seen in the spec or the status comes out of this thing here. So this goes and figures out all of that logic and essentially creates that intermediate DAG type object. I'm trying to see where example that would be. Yeah, so like this route here is a type dag.route. So then this gets, again, sort of mirrored in a way from what Kubernetes looks like. Once we have all of that stuff, that ends up into this DAG here. Let me return that back. So once we have that, we'll trigger this onChange event. So I can pause here if there's questions in the middle.
Yeah, I've got another question, Steve.
Sure.
Sorry, I don't mean to hijack. Okay, so this DAG that you're generating, what are the relationships in terms of like, okay, so, you know, I guess, is it like a tree structure where you have, like, what would your highest level object be? And then what would the kind of child objects underneath that look like? Like, is there kind of like do you have like a top level object and then below that are like the services and then below that are the HTTP proxies? Or can it just, like, can it change? Is there some sort of hierarchical like concept to the DAG?
Yeah, I think it's based around virtual hosts. So I'll show you here in a second. So let's move to the next one, and then we can see how we actually like use that DAG and walk it. Maybe that'll help us answer that here in a second. So yeah, so we'll build this DAG, and then we'll call this onChange, and this onChange triggers a thing in all these different this contour package here. So let's go to listener. Knock my water over again, spill everything. So in here, there should be an onChange. This one's a big one. Yeah, okay. So here, so this gets called here. So like I said, from the builder here, or from this one, this is the handler. The handler goes and rebuilds the DAG, and then it calls this onChange event, which everyone's subscribed to it. So basically, all the XDS types are subscribed to that. So listeners, clusters, endpoints, services, secrets, and routes. Those are all have the same event here. And what they get is the DAG here. So they get passed in the DAG. And what we do is then we go and walk that. So this one here, visit listeners, this will build out essentially, this will turn this into the XDS version of listeners that Envoy is going to actually consume. So what we do is we get the DAG in here, and we get the root, which is the top. And then what we'll do is we'll pick apart, see if we can follow that. We'll create a listener from here, and then we call visit. And then visit figures out basically where we passed in an insecure virtual host or a secure one, meaning is this just plain HTTP or is this a TLS version? If it's TLS, then we're going to go and build out the TLS config. So here's where TCP proxy, we'll ignore that for now. We're adding all the Envoy isms. So this is creating the actual Envoy bits. Here's the listener. Here's the filter chains that we apply. So this one gets a TLS filter chain because we're going to support TLS. Here's the fallback certificate stuff. And here's our default filter chains. This is, if you looked in the Envoy config for a listener, here's all the bits that we sort of apply here. So default filters like this gzip, the router bit, which you need to do routing. The metric stuff, the logger, and the timeouts and all that kind of stuff. So this bit, once this returns, then we recurse into it. So we'll visit itself. So I'm trying to answer your question. Chad. So I think the top level is this virtual host type, and then we'll visit itself again and walk down that thing. So we'll keep calling itself as we loop through this, because we call visit again down here. Yeah. And the visit will just call back to itself. Whoop, not to there.
So Steve, every time you're rebuilding the DAG, are you calling out to Envoy and regenerating essentially the entire configuration on Envoy?
Sort of, yeah. So the result of this visit, here, let's go back to where visit got called. Yeah, so here's the on change, right? So the DAG got built, on change got called. So we call this listener.update. So this updates the local cache with the supplied map. And the one bit we didn't talk about was how we map the XDS resources to the gRPC server that Envoy provides. So I guess the short answer is it's these values here. So these values and static values. So these v2.listeners, these are the Envoy protos here. So you can see I'm in this listener, come on, zoom out. This listener protobuf here. And this is the types that we actually convert them into. So then this can get converted to the actual protobuf to get sent over the wire back. But way back here in serve, when we spin up the gRPC handler, there should be a resources. Yeah, not that. Here. So this thing called a resource cache. So these are the bits here that represent the XDS caches that we're going to actually send over to Envoy. So here's listeners, here's secrets, here's routes, clusters, and endpoints. Now what happens is these get sent into, let's find the next one. Not there. Down here with the gRPC bit. Here. Yeah, here we create this new contour server. Yeah, so then what we're saying is when we create this server, we're passing in all those resources. And those resources have a type URL, which identifies who they are. So it might be, whether it's CDS, a listener, a cluster, a secret, that sort of thing. So this bit gets sent into to create the XDS server, so that when this gets started up, it maps basically those types that we saw, which are these different caches into each type. You know what I mean? So essentially when that server starts, when Envoy asks for listeners, it's going to come here and hit this cache here. So it's going to call into, there should be a contents. Yeah, here's a contents one. And you can see it returns a proto.message. So this is going to basically turn those two, the static one and then the values, into protobufs. Gotcha. And that gets passed off back to Envoy.
Okay, because it's Envoy that hosts the gRPC server, and I'm sorry, it's Contour that hosts the gRPC server, and Envoy is configured to connect into Contour. Mm-hmm. At which point Contour starts sending protobuf messages for the configuration. Is that?
Yep.
More or less. Okay. Gotcha.
Yep. So contents here. So this is part of the XDS protocol. So contents implements everything, and then there's a query as well, to where and we get the discovery request from Envoy. It can ask for specific things. So here it comes as names, excuse me. And then we can return, that smaller subset if it wants. Oh, here's the type URL we talked about. Yeah, so this should hit so here's again, we're back in the Go control plane here. So these are all the different types. So this would be the full type. So googleapis.com/envoyAPI.v2/listener/route configuration, or like here endpoints, see how it says cluster load assignment. I mentioned that earlier. That's behind the scenes what it's really called. I always call it endpoints, but it's really cluster load assignment. Yeah, so that's how the mapping between the XDS caches that Envoy, or sorry, that Contour serves, maps to that code. So essentially, in this Contour package, you'll have listener, you'll have cluster. So again, in here, we'll have the same type of thing. So this values map here is the source of what we send out to Envoy. There should be a route one as well. Yep, here it is. So here's the route one. And again, it has the same contents method with the query method. And you can see it's the same. Now the difference between, I think the only thing that's special is the listener. because you'll see we have that static values. And we use that to spin up. I think it's like the metrics endpoint. There's a couple of things that Contour configures. We used to do it in the Bootstrap config, and we since took that out just to make that Bootstrap config smaller. But basically, whatever gets passed into here, you can create listeners that just are always there, versus this one is dynamic, the values map. Yeah.
I had a question about the interaction, particularly between Envoy and Contour. Contour has leader election, but are all of the Contour pods active from an Envoy perspective, or is it only the leader that's responding to XDS requests?
No, so yeah, so from Envoy's perspective, yeah, any instance of Contour is valid to connect to and retrieve configuration. The leader election bit is only to limit one instance of Contour to write state back to the API server.
Yeah, understood.
Yeah.
So this means if you have even just a single Contour that has invalid state, it could potentially propagate to all of the Envoy proxies, or some subset of the Envoy proxies.
Yeah, whoever's connected to it. Yeah, right. Yeah. Yeah, so if you had two, yeah, so what you're saying, Joseph, you had two different instances of Contour running, and say, 2 envoys connected to the first one and 2 to the second one. In theory, if somehow the second Contour started producing invalid configuration, then half of your envoy fleet would have bad configuration. Yeah, that's true.
Yeah, and maybe a little bit. Yeah, so that's actually was going to be one of my questions, Joe. So thank you. So kind of maybe looking at it a little bit more. So when we deploy Contour and Envoy, how do those connections get established, right? So Contour has some sort of like chatter between all the pods to elect a leader. And is that like a persistent leader so that every time it's publishing config changes to Envoy, it's always from that same leader? Or do you have different envoys that connect into different Contours, or do all envoys connect to all Contours? how's that? Because I know you don't want like multiple configurations being pumped into Contour or into Envoy, like, the same configurations being pumped multiple times, right? So
sure.
How's all that handled?
Yeah, so leader election, just to be clear, it's only to make sure that only one instance of Contour writes state to the API server. So from an Envoy perspective, it doesn't know or care who's the leader, who's not the leader. Every Contour that gets spun up processes the same thing we just showed about. So you had two Contour pods running in your cluster. Each pod is going to have the same watch on the API, and it's going to go through the same workflow we just went through, to get the information and process it, produce a DAG, and send that information out to any Envoy that connects. Now, Envoy, when it connects, again, this is by how we've just configured it by default, is it uses this service. Let me show you here. Not that one. We want equals Contour. Yeah. So what we do is when you spin up Envoy, there's an init container. I'm sorry, Envoy. I'm in the Envoy pod. So this init container, what it does is it generates Bootstrap configuration, right? And this is the configuration that we feed to Envoy to basically go find Contour in the cluster, and a couple other things. So this init container, and this is one of those other commands we talked about over here. So there was serve, there was what's it called? Shutdown manager. There was the cert generation, and there's a Bootstrap one here as well. And so this Bootstrap knows how to generate this JSON file. And essentially, the big bits in here are the ones that you've got marked here. So this XDS address is what you feed into Envoy to tell Envoy where its gRPC server is. So in this example here, we're using Contour, and Contour is the service that we get deployed. So out here in these examples, we have this sample server or service that Contour gets deployed. So this name then is a DNS name that Envoy can use to find Contour. Now, because it's just going to return, it's a service, it selects many pods. So again, in our example, we had 2 different instances of Contour. So when this spins up and this Envoy goes to connect, it'll ask Kubernetes, hey, I'm trying to connect to Contour over port 8001. And then Kubernetes will pick one of the 2 pods or 3 pods or however many replicas you have running, just to let that Envoy connect to. At that point, I think Envoy will be a persistent connection then. It won't try this again. It'll connect to that one instance and keep it there until that Contour stops serving. If that Contour would go down, it would reconnect to a new one. that makes sense. So you could have any number of contours running any number of envoys, and each envoy will connect to whatever one it gets to first based on
Right.
round
Right.
robin. I think is what it still is in Kubernetes.
Yeah.
Yeah.
So how is that state replicated consistently then across the envoys? Does Envoy replicate state and configuration state across its all deployments? Or?
No. I mean, Envoy is just going to connect to its version of XDS server. So whatever instance of Contour it connects to is what it's going to be, and then you're relying on each Contour having the same exact processing logic. So in theory, if you had a whole bunch of contours running, each contour could somehow have a different set of config based on the time it got the events and process and that sort of thing. So it is potential that you could have that problem.
Yeah, but but Contour is going, like, let's say you have 3 replicas, right, of Contour,
Mm-hmm.
and Contour is going to select a leader, right? And only that leader publishes configurations back to Envoy. But if you have, like, let's see, three envoys and 3 contours, and they've all been round robin, right? So that every envoy is essentially connected to a different contour, but only one contour is publishing information to one of the envoys.
No, each instance is going to publish no matter what. Here, let me see if I can draw something real quick. Drawings. So if you have, let's get a shape. All right, so this is going to be a contour. Like that. So let's have 3 of those. And then we'll say, when these start up, we use in client Go, there's built-in logic to do the leader election stuff. So it's not code that we wrote, but it's just comes from baked into that. Let's make this one the leader. So this person is the leader. Just for example's sake. And then we'll make, I don't know. It's gonna be funny, but maybe I shouldn't be funny. We'll make this one. These are envoys. Envoy. Right, and then we'll make this purple because envoy is like pink. There we go. So you've got 3. Oh. So again, there's a service in the middle here that it's going to connect to. Contour service to pick one of these pods. So when this spins up, we'll do an arrow. It's going to connect. It's going to go from here, hit the service, and then pick one of these. Say it picks that one. We'll just go in a line. So now at this point, each instance of Contour is watching the API server and building its own configuration and everything up. So essentially, each one, here, let's do this one. There's a database here, I think. This one. Right, so each one maintains its own separate XDS data store. And that's what gets passed down to each envoy. So in theory, yeah, these could somehow get out of sync, making each one of these envoys not all exactly the same, potentially.
So what's the role of the leader then? Like, for example, okay, so in front of those envoys, you're going to have your load balancer, right?
Mm-hmm.
And your load balancer is going to connect to these envoys, and it's going to essentially distribute traffic, right, to all of these envoys here, right? Yes. So if your leader is the one that publishes, then the only envoy that's getting updated information would be that second one, right?
No, so this leader is only deciding who should write status back to the API server. So on those HTTP proxy objects as well as ingress objects, what we want is we don't want 3 writes of the same information to the same object. Right. So we only use leader election today to decide only one person should write that status back, and that's the leader.
And that's back to the Kubernetes API server.
Yeah, right.
But all of the contours serve XDS to Envoy.
To all the envoys. Okay. So what statuses go to the Kate's API server then? Like, what status changes would go to?
Yeah, so things like we describe this. So like this right here, this is valid proxy. Or if if I edit that, was it? I come in here and I make, say I change this service to be something that doesn't exist.
Mm-hmm.
And then I describe again, you'll see it's invalid now because this service root blah, 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 blah is not found. So when I changed that proxy object, Contour got that message. So I changed that status in the API server. Each instance of Contour went and got that event, said, hey, this proxy object got updated. Each instance of Contour went and built a new DAG in memory.
Mm-hmm.
And then out of that DAG rebuild, it found out that this service wasn't found.
Mm-hmm.
So there was a set of statuses that got set. So then that bubbled up through, and then each instance of Contour figured out that same error, but only this one in orange here wrote that status to the API server.
Right. Okay.
But
Cool.
but all three envoys got the exact same change. But again, I mean, speaking in reality, technically, because each one's processing its own XDS cache essentially, based on the events that come out of Kubernetes, there is potential that one of these could be out of sync somehow. And your answer there, I guess, today would be just to only run, one Contour. And that would ensure that all envoys would have the exact same configuration, right or wrong. Again, it hasn't really come up, been an issue, but maybe it has and we haven't seen it, or, I mean, you saw how fast things got updated. So it's never really been an issue, but yeah.
Yeah, like there are other ways to handle that as well. Like you don't necessarily have to make everything consistent by electing one leader and then routing all the envoys to it. Another way to make it so that the worst case scenario is to have contours shut down or kill themselves when they aren't able to connect to Kubernetes for a significant amount of time, stuff like that. There are other ways to prevent configuration drift.
Yeah, fencing, essentially, Joseph, is what you mean? Like some sort of fencing mechanism?
It's not really fencing, it's more just like a health check, right? Am I actually able to do my job of updating this XDS cache? If not, then I should shut down.
So I do know that there is, excuse me, there's a readiness probe. So 8001 is the default for the Contour XDS server. So if that stops responding to internal probes from Kubernetes, that instance of Contour will go unhealthy, and then Envoy should connect. Also, there's a liveness probe, and it's this health Z thing. And I think I wrote this forever ago. But I think it tries to do a query against the Kubernetes API. Yeah. And what it does is it tries to hit, that's a different thing. It tries to do a query out to the Kubernetes API.
Nice. Yeah, that should alleviate a lot of the concerns.
Mm-hmm. And if it can't, then it'll fail that liveliness probe, and that should force Contour then restart. Yeah, it tries to get the version of the server you're connecting to. And if it can't, then it basically blows up. It'll fail that liveness probe, which should cause Kubernetes to restart that instance of Contour if for whatever reason it can't connect to the API server.
Cool. Yeah. So with Linux clustering, right? If you look at other Pacemaker and some kind of the service, if there's if there's services for example, services that manage disks and persistent data that require to be consistent, have consistent data, they implement a protocol called fencing or stoneth, which is shoot the other node in the head, which essentially kind of guarantees consistency in case you get something that acts up, right? So I don't know, I'm just trying to kind of think of if there is an issue with inconsistency based on this, I think there's probably lessons learned from, how distributed systems are handled, clusters are handled essentially, maybe in some other scenarios. So.
No, absolutely. I think, that would be great to, dig into and see. But yeah.
I mean, I think you sort of have to accept that you're in an eventually consistent world, right? Your source system, Kubernetes, is eventually consistent. And so the contours and the envoys are all eventually consistent. And in practice, it seems to work pretty well. But you don't have that guarantee of consistency at any given point in time.
And I think a big win how that hasn't been a problem is because the way I mentioned that, the builder goes from scratch every time, right? So based on that cache, I lost wherever it is, but that resource cache that we have, it generates it from scratch every single time. So if for some reason an instance of Contour did lose a message or didn't have all the information, that should catch up eventually, and then the next rebuild would have everything in it, essentially. So. Yeah, it could happen though, I think. Yeah. Good things to think about, I think.
Cool. Yeah, this was so helpful, Steve. Thank you for going over
Yeah, no worries.
This is awesome. It totally makes sense to me. I think. Well, so, as I learn more, it was helpful. So.
Yeah, no, it can be a lot. I mean, it's there's a bunch of moving pieces and things in there. But end of the day, it's just have a local cache of Kubernetes, process that stuff into that internal type, and then convert that into Envoy types. So it'll get interesting when we move to the v3 stuff, the XDS v3, because we're going to explode out this internal bit. So that's all this Envoy package here. That should explode.
So how does the new v3 stuff, like where is that change? Is that Envoy has essentially changed its protobufs to like a new format, or the Go control plane? So how does that fit in this kind of?
Yeah, sure. Yeah. So when we go out and build, here's an example. So here's the Envoy package, and we'll look at, say, cluster for fun. So in here we spin up basically, see how it says v2.cluster, and this v2 is representative of this. So we use the Go control plane because they give us the Golang protobuf prototypes. So here it's /v2. So we'll hop out here into Go control plane. So that should be in what? Envoy API v2. So Envoy API v2. So this is all the stuff that we consume today for the protobuf stuff. And then the v3 stuff, I know they copied it. Where is it? I'm failing my interview. There should be, I know that, here it is. Yeah, so now it's in this stuff here. So here's v2 and here's v3. So let's find. No, it doesn't seem right. Anyway, but essentially I'll have to find them. I don't know why. It should be. What's this just in here? Okay, here it is. Yeah, it's like here's cluster. It's a CDS. So before we looked at, here, let's pull this up. Yeah, so here's cluster protobuf here, and then here's our cluster, but the v3 version of it. So generally what Contour is going to have to do is just swap out basically all those different paths. So right now Contour pulls clusters from this v2 package. We're going to have to pull them from the v3 package, and then also update whatever might change. So I'm not sure what's different. I don't think there's a whole lot different, but whatever's different in v3, we're going to have to then replicate here in Contour. So I think our plan was to have, again, another flag until we fully, so you can decide if you want to go to the v2 one or the v3 one. So you'll have a couple of options now, is running the internal Contour XDS server, the Go control plane XDS server, and then you can decide on if you want v2 or v3.
So v3, you're still using like XDS, you're still using gRPC, you're still using protobufs, but the v3 protocol gives you access to new features in Envoy, essentially.
Yeah. So they stopped developing on the v2 side, and now it's all v3. So now v3 is where all the new stuff's going to go into. Yep.
Interesting. Okay. Cool.
Yep.
Cool. And I'm sorry, one more question, Steve. So
yeah.
In terms of like leader election, right? We'd mentioned, obviously you can spin up as many replica sets as you need. And I would assume, do you guys suggest like running daemon sets, for Contour, essentially to kind of put that processing on all the nodes? And if, does your leader election, like, does it require like a three node kind of election? Like, is there a risk of like a split brain scenario type of thing, or is there some sort of what's the term I'm looking for, a consensus that requires like three or more, essentially?
Yeah, no, I think so. A lead election is done with a config map today. So in client Go, there's a here's an example of the code. So I think what it does is someone tries to write to a config map, and whoever gets that one first becomes the leader. So it uses Kubernetes as its generic store for or its central spot. You can, I think there's any number, you could run 1 or 100, doesn't matter, because it's all based around using that one, I think, config map that it's doing today. So yeah, so it's again, we didn't write it. It's this thing here where it's all built into the client Go library, or the Kubernetes library that does all that stuff for us. I don't know the ins and outs of it. I Nick did the initial implementation of it, but this would be where I think to go look if you're curious about how it works. But yeah, it creates this resource lock here, and then it uses I believe a config map to be the resource to lock against, and whoever gets that lock will then become the leader.
Cool. Okay. Awesome. Yep, that makes sense.
Steve, I have a question. So you were around when a lot of the original code was written, and I'm curious what the original motivations were for having the DAG representation, like having that intermediary representation, rather than just going straight from the Kubernetes APIs to Envoy types.
Yeah, I think the original motivation was when we introduced ingress route, and the goal there was because of you need to be able to understand, like, hey, how does so someone got delegated a certain resource, so /blog or /whatever. I think the original idea was to be able to walk through that to find those different issues. That's why that DAG got created, was for ingress route, to find those issues of, but we don't do that logic in there. Yeah, we walk it after the fact.
Yeah, because I mean, it seems like an alternate approach would be to just go straight to the Envoy types, and as you're doing that, put whatever validation you want in there. I mean, I can, as you were talking about the V2 to V3 stuff, I think that's a good example of why having the DAG is useful, because without that, if you want to be able to work with V2 and V3 at the same time, then you would have to like rewrite every one of your processors to support both. Yeah. Whereas with the DAG, it's just go from the DAG to either V2 or V3. So.
Okay. Yeah. So I know. So Dave Cheney did initial work on a lot of this stuff. So the idea was the Contour package would process through to figure out how this DAG stuff should get built or how it should look. And then the Envoy package was the Envoy proto representation of that stuff. Yeah. So once you got past, that builder stage, then you shouldn't, Contour shouldn't care where the data came from, whether it was an ingress resource or an ingress route resource or, service APIs or whatever. Yeah. So there was a separation between, who had to deal with what types. Yeah.
But it makes a lot of sense if you're in a kind of many-to-many scenario, right? Where you're supporting multiple, many different Kubernetes APIs for describing ingress, whether it's, Kubernetes ingress or HTTP proxy or whatever else. And then on the output side, you have many outputs. So on XDS v2, XDS v3, it makes a lot of sense there, because then you don't have to map every input to every output. But if you only had one output, if Envoy, if a single version of Envoy is the only output, then maybe doesn't have as much benefit. So I was, kind of just wondering if there are any other insights as to why that pattern was chosen.
Yeah. I think if we only process ingress, then you're right. Going to that, that intermediate type in the middle isn't all that helpful, but yeah.
So
I had a tangential question. So related to all of that, that was obviously how include support is built, so you can have child HTTP proxy resources. I've seen it raised a few times, but not really explained. Would it be antithetical to Contour's design to have parent references? So instead of having to define a root with all of its children, you could define that a root allows children, right, that match in a certain namespace or something, and then have the children reference the parent. And the use case for this is cases where you want to generate a lot of resources that point to a parent, but you don't want to have to regenerate the parent or update the parent every time you're adding one of these.
Yeah. So this has come up a bunch of times. Yeah. So the original goal of ingress route and then HTTP proxy was to allow some security around ingress, right? So today you could have two different users could create the same domain name and the same path in two different namespaces, and they would conflict. So the way we ended up doing that was with having that delegation or announce and includes model, where from the root, you work down from the top down in terms of who has permissions to do what sort of thing. And that was just because that's easy to then implement that security model, right? So if you're a user on the side here and your parent hasn't given you the right permission, then to use some sort of resource, then you get thrown out. Now, what you're talking about, Joseph, is sort of the opposite. And folks want to do this more of like the Ingress model, where it's more self-service, where folks can just create a resource and then have it all kind of tie together. I think we just need to just think about how we break some of those rules that proxy gives you today in terms of that. What happens with conflicts? I guess we just have to understand, how. So maybe you have a good model of the child going up to the parent saying, "Hey, I want to do this." We just need to figure out how those things can get, understand what comes out of that model and how we can implement that without, just so it's clear that if you do this, maybe we'll break it because there's conflicts or X, Y, and Z. We just need to just think about it because it comes up a lot. Folks really want to do that, have that self-service model. They want to have that root, generated all the time.
What I was more thinking is not just the free-for-all model where it's like, yeah, I'm running here, but more like the root defines which namespaces can be included and like things like that. So it's like basically just inverting some of the thing rather than being directly, I include specifically this child. I will allow child resources that match this policy. As a way to make it more secure than the free-for-all mode. Now, an example of where this was like a little difficult was I was implementing contour support for a system called Selden. Selden is a machine learning platform. It's a serving system, effectively. So it's similar to like Knative and things like that. When you brain's not working. When you want to host a new machine learning model, it'll spin up the Ingress resources to wire up everything to TensorFlow serving, etc. And part of the problem is the way that platform is designed to be built is the models sit behind a single endpoint with path-based routing. So to implement that in Contour, you need a single root HTTP proxy with includes, and it's a little hairy.
The same problem. My colleague actually wrote the issue that is introducing this problem or describing this problem. And in our case, it's mostly because the problem is that we are doing products that are deployed on Kubernetes environment of somebody else, and we are not like maintaining that then ourselves. We do not have teams who would be like DevOps teams who would be developing applications behind a single virtual host, but instead we do a product which is then deployed at customers of ours, and that product needs a certain level of modularity, that whatever parts of that product are deployed should then appear behind that virtual host, and that would happen on deployment time. The decision of what is deployed, we have then options to choose certain parts of the product, and we basically would then need to generate this top level HTTP proxy at customers, because only at that time we know what goes behind that virtual host, and so it isn't any more development time effort, but it would be done somewhere else. One thing that I wondered about this validation and conflicts, that what is then because for me the conflicts, the potential conflicts can happen even when we have a cluster administrator who writes, let's say, 2 includes in a top level HTTP proxy. So aren't all of those potential conflicts somehow solved already today, even with this model where we have the cluster administrator including? What is the difference when we compare that to the case where we would say that include all HTTP proxies in this single namespace?
So yeah, I think, I mean, the HTTP proxy model, yeah, its goal there is to help you eliminate some of those issues, but I mean, conflicts can still come up. I mean, an administrator could create, the same domain name twice, and then Contra will find it and mark them both as invalid. I know some of the work that Steve did with the gatekeeper stuff could be an interesting thing of maybe,
Right.
we talked about doing this, could we somehow expose the DAG somehow? So gatekeeper could look at that and understand, hey, there's already a route for this, or a user trying to create some sort of object, you don't have the right permission to do that, and then not get to that point where we mark that as invalid, and then we break both objects.
And that would be like equally valid for this current model,
Yeah.
where the administrator is adding the includes, because it's the same problems will happen regardless if somebody does a mistake.
But so far that doesn't change the issue of how you define that permission set, and that's what you're bringing up, Joseph, of like, how does a user say they can, how do you create those rules, I guess, is sort of the part B is, how can you implement the security of it? And then 2 is how should we change the model so it's not the same and it's just different.
I was just wondering that if we I think that it was written in the ticket that that we just need to have a design document that explains the corner cases and whatever validation needs to be done for the merging and validating that the merge will be then okay. Mm-hmm. So I was wondering that is there something new that could be done in that? What would be put into that design document when comparing to the currently existing resolving algorithms that there? For example, algorithms that resolves everything for ingress currently, or whatever checks are made when the cluster administrator adds a second include in the top level. So would it be like describing collecting those, or would there be some additional checks that we could put into that design document? I'm not making any sense.
Yeah, I'm trying to make sure I understand. Yeah, so I think we're talking about of changing how HTTP proxy works today, so we can make it a little less restrictive in terms of how clients or users in different namespaces can create objects. It's come up a few times. There's been a couple of different things. I know one user said they wanted to have like a first come first serve. So I think like if you're there first and you get a path, then you own that path. You know what I mean? Which is kind of interesting. So there's some different things to think about.
What happens then currently if we have like a include in the top level, and then we add a second one, which then happens to overlap?
So what's the question? If you have a root has an include, and then
is that possible? I mean, yeah, I'm kind of trying to understand that how what is the difference. So now that we have currently we have the include, it will be always in the context of some prefix, or so that there is no possibility of overlapping. Is that the case in the HTTP proxy? When you add an include, there is no possibility of overlapping.
Yeah, you shouldn't be able to. Yeah, so if you create, say, 2 includes for /blog or something, Contour should complain and say, hey, you can't have 2. You can't delegate the same path to 2 different places. That should be an error. You can do, like, you can have a root delegate to a child and have the child then delegate further, right? So if I give a namespace /blog, for instance, that namespace now, that proxy object now owns that /blog, and they can take whatever they want out of that and delegate further if they need to. So which is interesting too, but it still requires you from the top down to define that kind of hierarchy, which for some users they like proxy, but it's too restrictive. It's too much. You always have to update. You always have to have someone update that root piece, which can be tricky sometimes. Yeah.
It is tricky for us because we do not have anybody to update that at our customers, and so that kind of removes the possibility of having the application modular, like install more services at customers, because somebody need to go and modify that.
And I know
Yeah.
Sorry, go ahead.
Yeah, then I was wondering that at least for Ingress, because obviously Ingress has this overlapping paths problem. So for Ingress, there is some algorithm already in Contour that merges those paths and does this kind of decisions of who wins first, first gets the path.
Yeah, I think it's last in will get it, because the way the Contour internally maps new routes and stuff. I think the last one in will overwrite. So you won't get an error. You'll just get the last person will get the resource.
So would it be so that if one would go and try to draft a design document for this feature, can we draw motivation from what Contour does for Ingress for those conflicts?
Yeah, so let me go pull. I can go pull out. There's a bunch of issues that folks have already opened up and chatted about, and have a bunch of things in there. Would be good starting places to look through. I think the other thing to think about too is there's the service APIs work that's going to be getting added to Contour here very soon. So it may have a good middle ground as well in terms of it has some underpinnings of what we've done in HTTP proxy, but also doesn't have all the same things that Ingress had. So it may be a good middle ground for folks to implement if they're willing to switch to that. But that's obviously not in yet, and it's not a final spec just yet. But yeah, let me go find those issues here, and if you want to read through them, you can see some of the ideas that folks have asked about, and just putting together the use cases would be great as a first start, and then we can start addressing, how do we make it a little less restrictive but still usable for users. Yeah, I'll do that.
Thanks.
Yeah. All right. So we were 5 minutes past. I'm happy to chat if folks have more questions. Otherwise, I'm pooped.
Not from me, Steve. Thank you so much, man. I really appreciate your time today.
Yeah. No, thanks everyone for coming. This is great. This is great to have everyone. This conversation's awesome. So I think the next one scheduled is September 17th, which is 2 weeks away or so. So yeah, that's all. If y'all in the US have a happy holiday this weekend. Otherwise, everyone else have a nice weekend. We'll catch y'all in a little bit. Take care.
Take care. Bye-bye.
Hi, everyone.
Yep.